I'm going to show you guys how to use the Cauchy-Schwarz inequality to solve this question. The goal is to find the minimum value of x squared plus y squared plus z squared, where they are just the distance here, here, and here, and we are talking about here we have this 3, 4, 5 right triangle, and just a point somewhere in the triangle, and it's a distance from the point to each side. Now, this right here is actually not about the Fermat's point. That can be a topic for another video. Right here, notice that we have the square of each term, right? Here is how we can use the Cauchy-Schwarz inequality. Here we go. Let me just write down a statement for you guys right here first. Cauchy-Schwarz. And the reason that we know whether we can try to use this is because that we have the square. I think that's a pretty good hint. Because when we use this, and then of course we have 3 terms, so let's use this version. A squared plus b squared plus c squared times 3 other things, and each of them being squared as well. So let's say we have d squared plus e squared plus f squared. This right here is going to be greater than or equal to, ready? We do this times that, which is AD, plus this times that, which is BE plus CF, and then square. And in fact, this right here can be easily derived from the dot product of 2 factors, which each factor has 3 components. And you guys can think about that. Or you can just take this and I'll show you guys how we can work that out. I do know that we have the equality here. So when is that going to hold? Well, I'll talk about that later. Firstly though, you see that we have the sum of 3 squares here. Okay, that is pretty good. But we will need to have these, right? D, E, and F. So what do we do though? And in fact, we have the X, Y, Z. What are they doing inside of this 3, 4, 5 triangle, right? So the first thing that we have to do before we can use this is that we should have a connection between the X, Y, Z and then also the 3, 4, 5 right triangle. So how can we get a connection? Well, let's do this. I'm going to just break down this triangle into 3 parts, like this, and like that. And I'm going to talk about the area. So note that the area of the whole triangle, of course you can take this for the base and that be the height. So it's just 1/2 times base times height. But this right here, it's also the same as the area of this smaller triangle plus this one plus that one. And because we're talking about this is the distance from the point to this side, so it is going to be perpendicular. Take this for the base, take that for the height. For this triangle here, we first have 1/2 times base times height. And then do the same thing for the next one. I'll just put down plus 1/2 and then 4 and then y. And lastly, that, which is 1/2 5z. And since everybody has a 1/2, we can multiply about everybody by 2. And you will see that it's just going to give us this connection. 3x plus 4y plus 5z is equal to 12. Much better. This right here is like the constraint equation that we need. And if you really want to use multivariable calculus, which is the Lagrange multiplier, to find the minimum of this expression, go ahead and try that as well. But Cauchy's inequality is actually really cool. So how do we continue? Well, it's kind of like filling the blanks. Right here, I'm holding 3 markers in one hand. Let's see if I can do it or not. Okay, I'm just going to kind of fill in the parentheses like this. First off, we have the x, y, z. So fill in the parentheses right here. Yeah. And this is how we know that we can try to use Cauchy's inequality because of the squares. Now, to fill in these parentheses, 3, 4, 5, right? Just like the given 3, 4, 5. So let's go ahead, 3, 4, 5. And the reason that I know that I'm going to put them down right here is because when I multiply x and 3, we get the 3x. And then when we do this times that, we have the 4y. and then lastly phi and z, which we know that this right here is equal to 12. So this right here is a constant. This right here is just a number. So you can solve for this expression in this inequality. And maybe sometimes it's better if you actually fill in this part right here for your constraint equation, and then fill in this right here. But this right here, I think is pretty clear. So now let's see. This right here will tell us, right here we have the sum of x squared, y squared, and z squared. This is 9, 16, 25, so that's 50. It will be greater than or equal to, this right here is 12. The blue one right here is 12. Yeah, so it's 12 squared, which is of course 144. I don't have a platform to put my markers, so yeah. Anyways, right here I'm just going to divide 50 to both sides, so we see x squared plus y squared plus z squared is equal to, that is 144 over 50. I know this right here should be greater than or equal to, I'm sorry. And then we can reduce that very nicely, which we will know that x squared plus y squared plus z squared greater than or equal to 72 over 25. But wait, we are not done yet. Because this right here is just an inequality, right? We know this expression is always going to be greater than or equal to this number. How can we be sure that this expression can be equal to this number? Well, we have to find it. Right here, I will tell you guys that for Cauchy's inequality, with this equality here, right, this only works if the condition A divided by D is equal to B divided by E is equal to C divided by F for the equality. So in fact, let's just go ahead and set this up. Right here we have this divided by that. So I'll just say for the equality, we must have x over 3 being equal to y over 4, and that's equal to z over 5. Let's just kind of play around with this right here real quick. Look at this, multiply both sides by 4. We know that y will be 4 over 3x. And then look at this and that, multiply 5 to both sides, z will be 5 over 3x. Now plugging this right here into here and here. And you can just go ahead and solve for x. I will just tell you guys the answer. X will be 18 over 25. Once we have that, y will be, you put that right in here, and then you will see 24 over 25. And lastly, you will see z is equal to, plugging this into here, z is equal to 6 over 5. And then I'll tell you, if you square this, and square that, and add them up, you will get 72 over 25. We can see that this right here has the minimum value of 72 over 25.